and gentlemen, we'd like to thank our sponsor, Nations Neighborhood, for their support of the event, and we'd like to invite our sponsor representative, Ms. Elise, to have the introduction of the product. But before that, I would like to read some of her background. Over the past 6.5 years, Elise was a progressive role at Lattice Creed as a senior specification consultant for 4 years, assistant manager of strategic account group for 1 year, and currently serve as a regional product manager for Southeast Asia for almost 15 years. No, 1.5 years. I was like, increase your specific details over there. Looking forward to that. Okay, so her expertise expand product development, specification strategies, and technical training, introducing high-performance flooring system for mission-critical environment like a data center. So I hope we gain something more, because it's very technical, and I see that everybody's still sleeping. You want to do some exercise? Dana? Okay, so without further ado, I would like to invite Ms. Elise. Thank you.
Right. Good morning, everybody. Okay, so let me see if I can adjust this a little bit. She's much taller than I am. Right. So good morning, everybody. As she kindly introduced, I'm Elise, representing Lattice Creed today. So Lattice Creed, I think some of you, or maybe most of you, may not have heard of us before, right? So Lattice Creed is actually a US company, and we are actually involved in these areas. Basically, we are talking about adhesive and grouts, we are talking about sealer cleaners, resinous flooring, your self-leveling, waterproofing, and so on and so forth. Okay? So we have footprint over 100 countries and territories. What does this mean? Basically, it means that we actually have the expertise in different climates, different site conditions, right? Different demanding conditions, basically. Right? And it also means that today, if we have new things coming into Malaysia, for example, a data center may be something quite new to Malaysia itself, right? So, but whether the product itself is new or not, and what are some of the things that we can help minimize the issue that can happen, I can always very easily tap into our different countries' expertise, because something may be new in Malaysia, may not be new overseas. They have done it so extensively already, right? So this is not just talking about data centers, we're also talking about materials such as your drywall, right? So drywall, you have many different types of drywalls, that kind of things, right? So how do we minimize that possible potential issues that may arise? Okay, so Lattice Creed here, basically we have a manufacturing plant in Rawang, and this manufacturing plant actually manufactures for Southeast Asia region. So we're talking about Singapore, Philippines, Indonesia, and so on, right? So basically it just means that you don't need to worry about stocks, because we manufacture for different countries already, so we have to make sure that we have the stocks on hand. So these are some of the global project spotlight. Spotlight means something that I want to show you to make it wow, all right? It doesn't mean that the product is so expensive, it can only be used for this project, all right? So it's just something to shout out. So this is Capella Hotel in Sentosa Cove, Singapore. So this is basically they use our waterproofing. We also have the National Aquatic Centers in Beijing. We also did Atlantis. If you actually go to Dubai, the Palm area, so Atlantis is one of the main attraction, the main hotels to go for. So we supply most of the products there, right? So we also did Grand Hyatt in Bahama, all right, and a number, so on and so forth. The more recent one, something to shout out, I think some of you may be aware that earlier this month, right, the Grand Egyptian Museum was actually launched, right? So this is also majority using Lattice Creed itself, right? So these are some of the projects that we are involved in, right? So you can see ranging from museums to hotels to many different types of projects. So why Lattice Creed? It's mainly because we're involved in every single layer. We are talking about your screening, we are talking about your adhesive waterproofing, your sound control, right? Your industrial flooring, and so on, right? So when we involve in every single layer, we make sure that everything is compatible with each other. Why is this important? It's because sometimes there are companies out there that they only manufacture a single product, right? Like, for example, waterproofing. And the products can be really, really good. So I don't deny their waterproofing can be really, really good. But sometimes you will notice that your tiles don't stick well onto the waterproofing. Your tiles may actually debond from the waterproofing, right? And then you're wondering why. What happened? Because I specify really good adhesive, yet it's still debond. Why? You know? So sometimes it could be compatibility, right? So when I say compatibility, we are talking about materials such as bituminous. So a lot of time, because of costs, we want something entry level, we would tend to go for bituminous waterproofing, right? So bituminous-based waterproofing, they are not suitable to stick tiles on, right? They are suitable to be the final layer, right? So it's not something you want to stick your tile on. So nowadays, bituminous may not be very widely available anymore. So, but they have PU modified bituminous. So just take note on this as well, because that also actually impedes your bonding, okay? So with all this in mind, if everything uses Laticrete actually also offers comprehensive warranties. What we are talking about comprehensive warranty, meaning to say that if there's any failure at any areas, tiles debond, leaking, but if everything is Laticrete, we basically give you a warranty whereby we will cover completely the costs. Not just our products, but the cost to make good that area, your labor costs, your finishing costs, right? So everything is covered. So this is a single source warranty by the manufacturer itself, right? So you don't need to worry that your applicators 5 years down the road, they may not be around anymore, right? Because this is backed by the manufacturer itself, and the warranty is not backed just by Malaysia, Laticrete Malaysia, it's actually backed by the international site, our HQ site, okay? So what makes Laticrete different? So why Laticrete? Okay, so not to bore everybody with the products, I'm just going to go into case study straight away. So the first case study is actually Masjid Putra. I think some of you maybe, most of you would actually know about Masjid Putra, okay? Right, so Masjid Putra, we don't supply it initially, right? It was a different brand, but we came in when they has leaking issues. 30 years down the road, 20 over years down the road, you know, wear and tear happens, it starts to leak, right? And that's where JKR actually came to a few brands, and they were saying that, hey, we have this issue. We want to remove all the mosaic and we want to redo the entire thing again, but we have a little bit of problem. The mosaics is actually bonded onto your FRP panel. FRP panel, your fiber reinforced panel. Right? Fiber reinforced panel means if I were to do hacking, I need to do it manually. I cannot do, sorry, the leg is a bit painful. So I need to do manual hacking. Yeah. Can I? Sorry, because my leg is a bit swollen today, so I kind of need to sit. Okay, so apparently I cannot tahan standing for too long, sorry. Yeah? So Masjid Putra, what happened is when they need to do the FRP panel, right, it's sticking onto FRP panel. So when we do this using machine to hack, then you actually expose all the fiber. So when fiber is exposed, you cannot bond your tiles onto it. It's just not suitable. The surface is not suitable for it. So if I need to make it suitable, I need to basically you know, kind of cover it up. I need to render it, right? I have to make good the surface. Sorry. So to make good the surface, they are laughing already because I'm actually in quite a bit of pain, right? So to make good the surface, generally rendering you need about 10 mm thick. So 10 mm thick means you are introducing a lot of dead load, extra dead load onto it, right? So is it possible, can we thin it down? Not 10 mm, but can we thin it down to just 2 mm? We just want to resurface it only, right? So that the fiber doesn't come out, right? So to do that, most resurfacing products will start to crack because they are just not made to go so thin. That's why minimum is always 10 mm. So that's where we came in. We could actually provide products that can go as thin as 2 mm just to resurface that fibers that is exposed, right? So that you can tile onto it. So that particular product is the 370145 mortar bed, right? So it basically helped resurface it, and then we would use the waterproofing, and then after that we start to tile onto it. Okay? So of course, when we first provided with this solution, it's not so easy lah. You have to go through many trial and errors. I mean, they will make sure that you go through a lot of mock-up, right? So we did mock-up in various areas, and you can see the mock-up, they basically pond the entire thing for 60 days, right? And then they check it and make sure that everything is okay before they even consider to proceed with it. Okay. Right. So this is only some of the mock-ups shown, but in general, we did quite a number of mock-ups, and in the end, we managed to supply it, and this is how it looks like. So you can see this area here. This is basically the very thin resurfacing area. We're talking just 2 mm. That's why you can still see the tile, the mosaic linings and all that thing, the previous linings and all that, right? Because it's just very thin layer just to cover all the exposed fibers. And then the green color layer that you're seeing, that is the waterproofing that we are applying, okay? And then eventually we tile onto it, right? So this is one of the interesting case study. The next case study that is very interesting is IBS system, right? So our local developer who also have their own IBS manufacturing plant, then I think most of you can narrow down to how many possible developer already, okay? So what happened was they were facing a little bit of issues with some of their sites that is using IBS systems. The tile starts to debond, right? We are not talking mosaics, we are talking actual tiles. And then in not just one home, but many homes are affected. Tiles are just debonding, right? So initially the first phase, tiles debond, then they say maybe it's the adhesive. So the second phase, they change the adhesive brand. But again, the tile starts to debond, right? So that is when they was thinking, you know what, this is getting a bit frustrating. We need to get to know what is the root cause of the issue, right? So that's where they call in literally every brand in the market. I'm not joking. We are talking literally every brand. You can see every brand is here, all right? So every brand was asked to go and do basically their own system onto IBS, their IBS system itself. They said, I want it on dry area and wet area. Up to you how you want to propose, right? Whatever your system is, so long as it works, right? So that's what we did. And the pull-out test, generally pull-out test is 14 days or 28 days, right? They said 14 days, 28 days, everybody sure pass one. Problem comes 3 months later, 6 months later. So this is a 6 months long pull-out test, right? So you can see we actually did 4 different rows, and then this one is all different products. So 4 rows, because this is actually your 14 days, 28 days, 3 months, and 6 months, right? So in totality, we have 6 months. Okay? So every brand is there. So you can see, I'm not going to name them, but okay. Basically every brand, right? So from here, Ladicrete consistently came out as one of the top performers, right, and eventually became their preferred brand to use for their IBS system itself. Why we consistently came out as a top performer is not to say that our product is the best, right? Of course, I want to say my product is really good, that's for sure. But I'm not trying to say that everybody else's product is not as good as well. Products can be good, but a lot of time is the know-how, right? Again, IBS system may be relatively new to us. That's why a lot of time we are not aware on how to minimize or what are the potential issues that can arise when we use IBS system, right? So like just now, earlier on when I say that we have a global footprint, actually when it comes to this exercise, we actually literally just message our global site and they say, oh, okay, you're dealing with IBS system. These are normally the potential issues that may arise. How can we mitigate it? And that's why we consistently came out as one of the top performers because of that, right? So it's not just product, but it's also the know-how, right? So Ladicrete, other than just our products, we pay very heavy emphasis on our technical support, after-sales support. We are talking about going to site, sharing with them how to use the product. And of course, this one, every company also does that to a certain extent. But we take, we pay a lot of heavy emphasis on it. We go to site literally once every 2 weeks, right? The idea is to basically you know, workers, the group of workers change over time, and it's not the same batch of workers that's following you throughout the entire project. So the group of workers actually do change. So if you only train them the earlier batches, and then after that, you don't come again, a lot of time, the different batches of workers, they don't even know how to use your product. So we go very, very often. Idea is because we want to catch off these new batches of workers and guide them on how to use it. Okay? So we will check for your hollowness. We will ensure they know how to use the products, right? And they are very hands-on. Okay? So this is Masjid Putra. You can see my colleague wear until like Star Wars Padawan, right? Yeah, Star Wars, or Harry Potter, right? And she go all the way up as well. Okay? So that's how dedicated they are, right? And because of this project itself is not just our product, but also the services that we provide, JKR was actually very impressed. They referred us over to this project. So this is your Prime Minister office. Okay, so again, Prime Minister office is also the same. The dome is also leaking, also on FRP panel, right? So before that, we have to do the mock-up here, and then after that, it transfer onto the dome itself. So all this is done during COVID times. So if you notice your COVID time on newspaper and all that thing, right? Yeah, so this is what we were doing. And then now it is still ongoing, no longer the dome is done already. They like our service again, now they open up to other areas for us, okay? So that is basically Ladicrete in a nutshell, right? So we basically involve ourselves in various areas, your tiles and stone installation system, your flooring systems, and so on and so forth. And it's not just products, we make sure we emphasize heavily on your technical after-sales support to ensure that every system is installed, you know, and can last a lifetime, hopefully a lifetime itself. Just a small little trivia, okay? So Ladicrete International, we actually give lifetime warranty, right? In Malaysia, we don't give lifetime warranty. Just mind you, one of the reasons being is because our skill, our labor, the labor skills may not be at par, right? So that's why we don't give a lifetime warranty. But in US, we do. Okay? So that is the confidence we have in our products. And that's about it for Ladicrete, right? And so I will straight away proceed on to the next one, or straight away proceed on, yeah? Okay. So I'm going to stay seated, right? So can you get up the next slide? So like just now I've mentioned, we don't just deal with tiles and stone installation, we also deal with flooring, right? So flooring for today, because today's topic is about data centers, right? So we are going to talk a lot about floorings, all things that got to do with data center itself, right? So for some of you, do you actually know what is data centers and why is it even important in the first place, right? So first thing is most of the conveniences that we enjoy today, right, is actually made possible by data centers, right? Data centers are basically the backbone of your digital world, right? Without data center, a lot of time, many things today that you enjoy, it's not possible. We are talking about things like your Google Drive, your Gmail, your email, your AI, right? Nowadays, everybody's talking about ChatGPT, Gemini, and all that things. So your AI, your online shopping, your WhatsApp chat, your online banking, right? Your social medias, and so on and so forth. All of these apps that we use daily is only possible because there are data centers around, right? So these are sometimes things that we use all the time, but we never consider actually what goes on at the back end, right? So basically, that is what data centers are for, right? So data centers are basically specialized facilities designed to house and manage computer system associated components. And there are many different types of data centers. I believe she's going to share with you later on more about data centers itself, right? So there are many different types. You have your enterprise type, so that means individual companies, smaller companies like I mean, it's still big, such as Boeing and so on. They will have their own data centers. We call it the enterprise type. Or you can have the colocation type. Colocation is whereby you rent, but you rent a space from the data center, but you bring in your own servers and whatnot. So that's colocation. Or you can go for managed service. That means they provide you all the managing service. Or you could be the hyperscale type. Hyperscale is like your Google, right? Because Google, they are huge area, and then they are the provider of your cloud data. All right, so there are many, many different types, but one thing in common is they house sensitive equipments, right? So everything inside, whatever you see here, are all very, very sensitive, okay? So because it's sensitive, the first thing we need to do is to make sure the moisture is controlled, right? So moisture is something that is very, very important, and oftentimes we may or may not overlook, right? So why is because electrical risk. Your moisture can short circuit, right? And cause corrosion because all these things are metal, So you may cause corrosion, you may short circuit the equipment and eventually cause the failure, right? You also, basically, it's also very sensitive to humidity. Mold may grow as well if you don't take care of the moisture level, right? And of course, you also want to prevent electrostatic discharge. So all of this got to do with your moisture, okay? So these are the standards, right, when you want to test. When we test to see whether it's suitable to, to put in your equipment, all this sensitive equipment to run. So these are the standards that we are looking at. So moisture testing before installation falls under this. And basically, they're telling you that the acceptable limits is this 14.5 grams per square meters in 24 hours time, the moisture level, right? So that is your absolute maximum, right? So meaning to say, if you do a test and you see 14.5, a lot of time I will still say, please use the moisture barrier, right? Even though you see, 14.5, okay, ma, that's the standard, but that is the maximum, so don't push, anything changes, then you may actually go off already, okay? So when you use a moisture barrier, basically this is what it should give you. You should actually provide you with a surface emission rate of less than 0.1 perms, which we convert it will become 1.67 grams per square meters. So you can see it's a lot less, just now from 14, now down to 1.6. Okay? So that is the idea. We want to lower down moistures because, again, moisture will actually cause quite a number of problems later, okay, to your data, all these sensitive equipments. And the main one actually is static. So what is static? Anybody knows? I think most of us know what is static, right? But we may not know it in such detail. Okay? So I'm just going to show you a very cute video. Very cute, right? But that is static, okay? So static is basically friction. A lot of time it is electricity charge that's built up on top of a surface, and normally it's caused by friction, right? So we are talking about, a lot of time when we talk about electricity, we are very familiar with current electricity. That means current that's moving, flowing, electricity that's flowing. When we say static, that's the term, it's static, it's not moving. The electricity is there, but it's not moving. It's actually there on the surface, okay? So it discharges once you touch something that is conductive. So have you ever, for example, basically when you touch something that's conductive, there will be, yes, a spark, right? There is a jump in the electrons and so on, right? So from one material to another. So just now, how does the hair actually stand like that is because as you are doing the friction with the cloth, your cloth becomes negatively charged. Your hair is positively charged. So positive, they repel each other, right? So when they start repelling each other, it actually starts to stand up. And you see, you don't stand up in one clump. It actually separates out like that, right? Because, again, everything is all positively charged. It's repelling each other, okay? But the moment if these kids were to touch something conductive, right? Or something that is grounding, like your ground and so on, right? So, or your wood or something like that, then you will see that it goes off, it actually drops, right? So, for example, daily life, when we talk about electrostatic, have you ever experienced spark and shock when you touch somebody? Something happened, no, right? And then sometimes, we may confuse ourselves. I mean, not to say confused, but there are people that will tell you, if you always have that, it means your health not so good. Have you heard of that before? Yeah, you heard of that before, right? See, so I can see some people start nodding already. Yeah, because I don't know, it's a common thing that everybody say, oh, if you always have that, you touch somebody like shock like that, that means your body not so good. Actually, it is not caused by health, it is caused by friction of your clothing. So a lot of times, if a person likes to use polyester or a person that likes to wear nylon clothing, right, then these are easily charged up as you're moving. It will charge. But if you're a person that loves to wear 100% cotton, then you don't have this issue, right? So, and if you're a person who is like me, who likes to wear sports shoe, your rubber is an insulator. So basically, it doesn't allow you to ground, right? So you are actually keeping the the electric around you because it's not grounding well. So if you're a person who wears leather, then it grounds better. So you may not have that kind of shock. So it's not so much on your health, it's about your habits or your preferences in the fabric and the material that you like to wear, okay? So have you also find that when you print paper and your paper starts to stick together and you have to kind of pull it out together? So all of these are your electrostatic. And cling wraps. You know, when you wrap your food, the cling wraps, or you wrap your luggage, right? Have you ever wondered why that plastic can stick onto your luggage one? But then the moment you arrive, the country that you arrive, you cut open, suddenly that plastic don't seem to stick anymore, right? So why? It's again electrostatic. When they pull it out from the roll itself, it's friction, right? So it charges up the plastic. So that plastic is actually made out of polymers that is very easy to start charging, to basically hold static and so on. So that static plus surface tension basically helps you stick onto it, okay? But once, after everything is done, you move on and so on, and then you get your luggage, you start to cut, there's no more friction already, so it's just as a stick, right? So that's how it works, okay? So now that we have an idea on what is electrostatic, right, let's look at electrostatic discharge flooring. So there are certain situations where we don't want to have electrostatic, we don't want static electricity. Situations such as you want to ensure safety in a hazardous environment. Have you ever seen videos whereby somebody is pumping the petrol gas in their car and suddenly fire come out? Wonder why? Again, it can be electrostatic. Because as you are moving out of your car, you kind of stand up from your seat, you are actually causing friction with your chair. And again, depends on what you are wearing, right? You may actually be charged up, right? So a lot of time when you are actually refilling your car, they did say that the best habit to have is before you put it in, you touch the sides of your car, right? Why? Because you want to, your car is metal, right? So you want to actually transmit your electro charge from your body to out from you. So what happened is, okay, the screen kind of blanked off already. So what happened is if you were to happen to touch the nozzle, let's just say if you're fully charged, you happen to touch the nozzle of the fuel pump. So instead of the handle, you kind of don't know why you go and touch the metal part of that area, or maybe you touch the circular part that is also metal from your car, whichever. If it happens to have the gas fumes, then that's where the spark can happen, and you may have that fire happening, right? So it's rare, but this thing do happen when you have electrostatic charges. So safety for hazardous environment is very important. All right, so we also don't want it static charges because we want to maintain operational integrity in your healthcare area, right? When we do X-ray, when we do your ECG, when we do all this testing of your body, we want it to be precise. If you have static, then this precision may run, okay? We want to protect sensitive equipment, and also we want to prevent electrostatic discharge. So when it comes to data center, these are the two things that we want to look at, right? So again, there are areas whereby we want electrostatic charge. For example, like your cling wrap, we want to use it, right? But there are also areas whereby we don't want the electrostatic charge, right? because we want to prevent this. Okay, so ESD flooring, or your electrostatic discharge flooring, basically is a specialized type of flooring designed to safely dissipate the charge away from the body, right, into the ground. Okay, so the idea is we also don't want it to fluctuate. It has to be evenly distributed, evenly. It's not to say one moment fast, then the next moment slow, then another, So it has to be discharged evenly. Okay, so there are two types of ESD floorings. Okay, so two types. When I put two types, it means that you have conductive and you have dissipative. Conductive means you dissipate the static very, very fast. Dissipative, you dissipate it gradually, right? So when you look at this, you are thinking, what does it mean? So it means like this. Conductive, basically, you have less resistance. So when you have less resistance, your electric current kind of move faster, right? When there's less resistance, right? So conductive ESD flooring basically have only 25,000 to 1 million ohms of resistance. So it's very, very minimal. Dissipative is on the higher side. Why? Because we want to introduce a bit more friction so that your electrostatic don't flow so fast, right? So now when you look at this, you're thinking, does it mean that conductive is better? Right? Because flows faster, ma. I want the static off of me, ma. Right? It sounds better, isn't it? Why do we even need dissipative? Why not we just use conductive for everything? Right? So there is a difference. Conductive, sometimes when you do it too rapidly, that means it moves so fast. Oh, okay. Before I go there, right, the slides is later on. But keep that in mind, right? Okay, right. So conductive is used, basically conductive ESD flooring is used when you need to have rapid control. So for example, areas like when you're manufacturing chips, everybody now is talking about NVIDIA, right? Why? Because they manufacture one of the most advanced chip to support all your AI. So NVIDIA stocks rise up so much. So their manufacturing plant of these chips, right? They have to use conductive ESD flooring, right? Because these areas are very, very sensitive. They want to dissipate static super quickly. But as architects, when do you specify conductive? When do you specify dissipative? Actually, very simple only. In your mind, you just think, the user, do they wear normal clothes in this area? If they wear normal clothes, it's dissipative. If they have to wear special clothing, right, and you will have so many other special things in place, right, then it will be conductive, right? So meaning to say, generally, everything is using dissipative ESD flooring. You only use conductive when you have special uses. When you think about, the personnel is going to wear special clothing, they're going to wear special shoes, they're going to wear everything special, right? So that is when you use conductive. Okay? So why can't I use conductive for everything? Like just now I mentioned, why can't I use it for everything? Because it dissipated fast, ma. Bear in mind, your data center, the main reason why we don't use conductive is your risk of electrocution, right? When everything flows too fast, you must also remember data centers has a lot of high voltage power, your cabling everywhere. So if somebody were to accidentally touch, maybe bump onto the cables or something like that, if everything moves so quickly, so the power actually moves through your body also very, very quickly, it can be fatal, right? So that's why we want to, it cannot be so fast to dissipate. It has to introduce some form of resistance so that even if you were to touch it, you are still safe, right? I think you will still be hurt in a sense, but it won't be fatal, okay? So that is the idea. So generally for every other areas, you want your dissipative flooring. Only special areas like your manufacturing of chips and so on, that is when you use conductive, okay? So again, just now I mentioned the range, that among this range there is also an ideal zone. Sometimes it is too low, sometimes sometimes it's too conductive, sometimes it is too dissipative. So we want it to be at this ideal zone between this, right, 10 to the power of 5, that means 5 zeros at the back, right, for your conductive. And then for your dissipative, ideally, of course, they put there until 8 lah. But generally, we would prefer between the 6 and the 7, okay? So that is your ideal zone. Anything above that, you're approaching a bit too much already. So may not be so suitable, all right? We want it that sweet spot, basically. Okay? So this is how your flooring coating is going to look like, your ESD coating is going to look like. These are the layers, right? So at the bottom, of course, at the very, very base is your concrete. From there, we're going to introduce, again, moisture barrier to lower down the moisture. And then from there, we have to introduce primer, something sticky, right? So sticky so that you can stick your copper strips onto it also. And that stickiness also helps you. It's not just the copper strip, then you're going to also have your carbon. So this carbon is whereby it is to help, the conductive, evenly distribute everything around the floor. And then, of course, the top will be your ESD flooring itself. Okay? So it looks like this. When it comes to your concrete, right, you have to pre-treat it first. Like, it has to come to a certain standard that before I can actually do my coating onto it. So we are talking about concrete surface profile of between 3 to 5. 1 to 2 is too smooth. 1 to 2 concrete surface profile will be good for your sealers, but not so good for your coating. Why? Because your coating cannot stick onto it. More than 5, you say concrete surface profile of 5 to 10, it will be too rough. Right? It's not to say my coating cannot grip. My coating can grip. But then when you look at it visually, it's going to look very ugly. You know, it's going to be. Right? So when the rougher concrete surface profile is more for repairs. Right? You repair it to make it smoother. Right? So for coatings, because it's not to repair, you want it between 3 to 5. Right? So you're going to look something like this. This one here. Okay? Right, so the idea is we want to improve the adhesion. Okay, so after that is done, we will apply your moisture barrier. So moisture barrier, of course, different manufacturer will have different colors lah. Okay, it can be transparent like this. It can come in blue color and so on. Right, so the idea is you just want to apply the moisture barrier to basically lower down. So again, once you apply, you're going to take the machine to test. Right, the moisture level to test it. So if it goes to 1.5 something, then you say, okay, that's good. It means it's working. If you place it down and still see 14 point something, then you know that, okay, this is not working anymore, right? So something is not quite right, right? Either the product is faulty or maybe the area itself is too high moisture to the point that your moisture barrier also is unable to contain it. So if that is the case, then maybe coating may not be the ideal material to use. Then you may have to consider a different type of ESD material, okay? So that is the thing that you have to judge, right? So once you apply moisture barrier, again, now that is where you're going to start to do your copper strip. So your copper strip, you can see here, it goes all to your outlet. So the idea here is your outlets is where all the grounding is. When you put in your plug, right, do you always notice that ours is 3-pin plug? And do you notice that the top one is plastic? Right? And you're thinking, actually, what for? That part, what is it for, you know? Right? Because that top part is actually your grounding, right? Every socket must have a grounding. If not, you are going to risk electrocution. So it has to have grounding. Okay? So this copper strip is actually connecting to that grounding, that top part, that strip itself. Okay? So we want to connect it, and we want to ensure that it goes through the entire area. So the spacing is important. You want to space it between 600 mm to 1.2 meters, right? And every point, at most, the length, 1 copper strip every 100 square meters, right? So you have to make sure there's a number of it. You cannot just say that, oh, I have a copper strip here already, right? So then huge area before another one, then it will not work, right? So you need it at least every 100 square meters. You must have a strip, okay? Once that is done, okay, another thing I'd like to highlight, do you notice that they only apply here? This is sometimes what happens at site. They want to save on material. Okay? Generally, what we do is your primer, we will actually prime the entire area. It's not just for the copper strip, but sometimes on site, this is what they do. Okay? So they just want it to stick the copper itself. Okay? But once that is done, we want to start to apply your carbon. the carbon primer itself. This carbon is the one that helps conduct your spread, basically help you spread it evenly so that it actually conduct it to all your copper strips, and it connects it to the grounding itself. Okay, so the carbon primer acts as a conductive layer beneath your ESD flooring, and it allows for uniform flow, right? So the idea, like just now I mentioned, we don't want it to be one time high and then a time low. We want it to be consistent flow. Okay, so once that is done, that is where you start to apply your ESD flooring. You can see the bottom here is all black, so then your ESD flooring comes. Okay, so actually it's just that simple only. So that is the layers we are talking about, right? So we want to make sure that we have the moistures in place, your copper strip, primer, then your copper strip, and then after that you have your carbon in place, and then your flooring. So now with all this in mind, once you are done, again you do your testing. So later outside you can actually see we do have this magometer, right? Or sometimes we call it maggers, right? So basically it's just a machine to help you check the conductivity, right? So when we check, and then you will test the insulation levels, and that's where you want to see, is it at the sweet spot? Right? Is it 10 to the power of 5? Is it 10 to the power of 7? Or so on and so forth. Okay? Right? So, simple. What are the common issues with coatings? Right? Sometimes you will see coatings like this happening. You have holes, pinholes happening. Right? So this is very, very common. We're not talking just ESD flooring. We're talking even your epoxy, your PU, and so on. This is a very, very common issue. You start to have all these holes, right? Why? Is because a lot of times, as they are applying, the applicator tends to add on thinner, right? And then they will tell you that that's the trade, that's how we do it. So, I mean, it's okay. Generally, it's okay to add for your epoxy and PU and so on. You add thinner to make it easier to spread. So basically, you thin down the product so it's easy for them to use. But if you thin it down too much, the performance is also affected. Okay? So generally, they will add to make it easier, right? But the important note is when it comes to ESD flooring, don't add. That means this is something that has to be emphasized to the applicators, because applicators in Malaysia will use thinner. This is something that they have been using, that is their experience when it comes to coating. So it's something they do on a natural, daily basis, and they will tell you it's a must. Everybody add thinner one. But when it comes to ESD flooring, bear in mind, don't ever add the thinner, because when you thin down the product, then the conductivity may be a problem, right? So, and when it comes to data center, critical areas like this, it matters a lot, right? You want to ensure that the performance is there. Okay? Then sometimes you have this, right? It's not evenly spread. You can see markings like this happening, like certain areas thinner, certain areas is even, certain areas you have this type of marking. Visually, it don't look so nice, right? You look at it and say, oh, what's wrong with this area? Okay? So this normally happens because your product is not spread evenly. And why is it not spread evenly? Is because a lot of time they use their tools to the point that it's no longer very... you can see it's blunted already, this one. Right? So generally, it's actually quite sharp, right? And then as it's sharp, you actually have that kind of spacing in between. But over time, as you keep using the tools again and again, the sharpness actually dims down. It gets blunted. And therefore, the space in between became very, very tiny like this already. Right? So as you try to spread, it becomes very thin. Right? So that's why you have this type of things happening, right? You have the coating, certain areas is thicker, certain areas is thinner, right? And last but not least is the last square mount. Now this is very important because a lot of time the major issue is always at the last point. They use the product everywhere already, and then comes to the last square meter, no more product, right? Finish. So they have to open up a new set. But if I open up a new set for this last square meter, macam too much lah. If I use the entire product, so wasteful. So I use a little bit of the product, right? And then a lot of time they don't use a weighing machine to weigh, because your product, you got part A, you got part B, right? A lot of time it's 1-to-1, we just mix it 1-to-1. But now you're not going to use the entire set. You're going to use partial of it. And they don't use a weighing machine, they use visually, Visually, I look at it. It looks about the same, you know. Then, okay lah. Then you use. When that happens, a lot of time, your part A, part B is not at the right ratio. You will find that your coating, it starts to peel, it starts to bubble, it starts to have a lot of problem happening, right? Why? Because the ratio runs. And that normally happens at the very last mile, because that is the part that, you know, they have to open up a new set, right? So just bear in mind when that happens, you just want to ensure that these small little things like this is addressed, right? So that's about it for today that I'm sharing, right? So I hope that you have gained something. You got to know a little bit more about data centers. You got to know a bit more about electrostatic, right? So with that, I pass it back.
All right. Any questions for the speaker? Anyone? Tada. Okay, I have questions. Regarding the testing, so after you do your application,
Yep.
But before that you have to do the moisture testing, right?
Yep.
So after you do the application and then you do the test with Mega, do you do any moisture test?
The moisture test we have to do first before the maker.
After the application?
So generally, we will test the moisture first before we even apply the moisture barrier, right? The idea is because when we test the moisture first, we will already know whether the moisture is too high or is it within the levels where we can actually lower it down. Because if the moisture level is too high, we will also highlight it to you that even with the moisture barrier, you are unable to bring it down to the level that's suitable for coatings. So if that is the case, if it's, let's just say it's too high, then we will always come back to you and recommend maybe relook into a different material. No longer the coating, maybe something else, a different type of ESD options. But let's just say that it is within tolerance. So that's where we say, okay, it's within tolerance, I can use my moisture barrier. So once, that means I test already, right? Then I will apply. After I apply, I will test it again. So when I test it again, I want to see whether the moisture actually drops down to at least, 1 point something, or at least less than 14, So, because 14 point something, that's the maximum for your data centers, maximum on the standard. So we want to make sure that it's lower than the 14 grams per square meters.
That testing, is it the same method with the one that you did before application? Or
Yes, correct. It's the
kind
same
of
test.
testing?
Yeah.
Okay, all right. Any other questions? Okay, all right. Let me introduce architect Ho Shao Chin. Okay, boleh lah. Shaw Architects Sdn Bhd, a design-driven practice with portfolio span mission-critical commercial and lifestyle development, delivering high-performance architecture with speed, trust, and excellence. So precise. Over the past decades, she has transformed a two-person studio into a recognized name in mission-critical architecture. So we want to know what is mission-critical architecture, leading projects from global clients while shaping Malaysia's emerging digital infrastructure landscape. Her philosophy is simple, built with precision but lead with purpose. Shochin's journey mirrored the evolution of the industry itself, from local resourcefulness to international collaboration, from traditional design workflow to cloud-based delivery, which is what we are doing, moving towards right now. So her work blends technical precision with human storytelling, as she believes that every high-performance building should still carry soul, a sense of order, beauty, and belonging. So we won't see data center as only data center, as only a house, but also some storytelling behind it. So she continued to mentor and empower a new generation of architects to design fearless and adapt constantly and build meaningful, because her architecture isn't about buildings, it's about imagination, resilience, and human connection. Without further ado, I would like to invite Ms. Hao to the stage. Thank you.
Thank you, Siti. Okay, good morning, everyone, including senior leaders and distinguished members of our architectural community. It's an honor to be here today among so many who have helped shape Malaysia's built environment. This is not a technical lecture. It's just as many of you has built more than I have. So I'm here today to share our journey behind. Sorry. Oh, okay, thanks. Okay, I'm here today to share our journey, what it feels like being in Malaysia data center boom. It's just our stories behind the scenes of server. Okay. I was Xiao Qin before the data center boom, and I'm now Xiao Qin after the data center boom, thanks to the Mak Saleh and Ang Mo that glamorized and globalized my name. I like a little bit of glamour, so you can call me Xiao now. Okay. Okay. So today, I just want to entertain you on a relaxed Saturday morning. Here, there are 6 topics that I want to talk about. First, data center, or DC salient points. Second, appointment to completion. Point 3, install architecture. Shaping public perception. Our company's growth. And finally, reflection and purpose. Okay. So first we go straight to data center salient points. So what is data center really? I wouldn't go into details. You actually can read from BOMA guidelines. Okay. But one thing I want to highlight is about the component within a data center. Basically, data center consists of data halls, data halls, MEP rooms, network rooms, office spaces, security zones, loading area, and amenity spaces. So what's the most valuable space in a data center? It's actually the data halls. It's where all the servers are located, therefore the value sits. So means the bigger the data hall, the more servers, therefore the more revenue. Just like your commercial or residential project, where you have more NFA, the more profit you make. Okay. So unlike factory that people likes to reference to for data center, is actually totally nothing to do with floor areas. Factory profits come from tangible goods. Okay, you also can learn about data center from Plan Malaysia, KPKT for federal level, or Johor Plan Malaysia. So one of the things they highlight is sizes of data center. Data center is measured by power capacity. So in there, it actually highlights 3 categories. Small is actually up to 5 megawatt, medium is up to 25 megawatt, and large is above 25 megawatt. So our experience span across 3 categories, and the center project is actually our project. We just completed this year, August. So technology progressed very fast. Local authority couldn't keep up. Currently, medium size is actually considered small, and large is actually medium now. And large now is 100 megawatt to 1 gigawatt, as reported by Gamuda for the PD project. So DC is measured by power that it can sustain. Unlike other projects like residential or commercial, sizes are measured by total floor area and number of stories. Okay, so that concludes the fundamental of data center, components, and sizing. Okay, next. So our appointment to completion. I'll bring you through our journey from appointment to completion of our project during data center boom. So first, appointment. So locally, we always is appointed based on scale of minimum fee. Contract is just one, span from schematic all the way to CPC or CCC. And then profession indemnity is company-wide, covering exposure across projects. Then the COVID hits. Cloud services exploded. Service provider needed to scale yesterday. So global tech giants turn to Malaysia because Singapore is constrained by land, power, and water. So we are the logical choice because we are just next to Singapore and it's fast, connected, English speaking. Of course, we are cheap. Okay. Yeah. Then our appointment flipped overnight. Our contracts are all now based on man hours because of the global clients. And the contract is split into 3 categories, schematic, DD, and implementation. And PI is not even company-wide, it's actually single project professional in the MDD or SPPI, means every contract has its own PI. So to be honest, I miscalculated for the first contract because I didn't see in detail for the contract. So I remember I worked with cold sweat some of the nights because thinking of how 100,000s of premium miscalculation. Okay, yeah. And of course, lesson learned for the next contract, I built in the full premium. And you know what? They call me expensive. Yeah. Okay. So I have a tip for you. At that time, probably 5 years ago, we didn't have AI tool. Now that we have one, we can just drag drop those documents and ask it to highlight clauses that matters to us and wouldn't have missed all these important clauses. Okay, so also for manpower contracts, we are asked to submit man-hour charts, monthly for monthly claims. As being honest and straightforward as I am, I submitted the real working hours during our construction drawing production. We charted 12 hours days, 7 days a week, total up to 84 hours per week of working hours. And we are warned by one of our global clients that we have disregarded human rights, which global working limits is actually 48 to 60 hours, and Malaysia is actually 45 per week. But that's the truth. Malaysians architects sometimes have to spend that kind of time during crunch time. In addition, we are at that time trying to design and deliver new world-class typology overnight. Okay. So it makes me realize that while we are racing to meet world-class standard, it's okay. We couldn't meet world-class working limits. Yeah. Okay, next, building contract. So locally and previously, we always use PAM contract, which we know inside out. Then global client come with their master architectural service or MSA contract or sometimes FIDIC contract, depending on the client. So before we even can start a project, we need to digest 100 to 200 pages of new contract condition. But luckily, it's actually 70% of the contract condition actually is similar to PAM principle, so that's okay. And luckily, also global clients usually have their own PMC who manage the contract. However, it remains responsible for advising the client and contractual issues prior to execution by PMC. So for design approach, so local clients are experimental. They test, learn, and refine layouts based on real operational costs, operational experience and costs. First layout always come from MEP or DC specialists, designed by optimizing CAPEX and OPEX, and thereafter, as architects, we check for code compliance, coordinate drawings, and inject design source in this highly technical building. Whereas global clients usually come with their basis of design, or BOD in short, is 100 to 200 pages of their global design manual, where we have to digest again before we can even hit the drawing board. So all this study time is not even included in part of the production time. It contains room requirements, critical dimensions, structural preference, material selection, and operational philosophies. Okay, construction method. So locally, we are just using concrete and bricks because labor is cheap. We can deploy large site teams and run trades concurrently. Our speed comes from scale of labor. Another advantage is that there's less paperwork as there's less shop drawings or PE endorsement. Whereas for global clients, they like to bring in their own home country construction method, and usually it's steel building. Usually it's prefab steel building. The precision comes from system and precision. The speed comes from system and precision. But still, it's expensive here. In addition, it needs to be backed by hundreds of shop drawings, PE calculation, and endorsement before fabrication can even start. So both methods actually can achieve similar construction timeline. We spend time on manpower, but less on paperwork, whereas they spend more time on paperwork and less time on manpower at site. So understanding the balance allow us to influence client to pivot locally and adapt locally for cost efficiency while achieving the same construction timeline. Okay, for data center, hermetic envelope is very important. So the water tightness is to protect electrical equipment, and the airtight and thermal control is to control air leakage, to maintain pressure, to ensure cooling efficiency. So for concrete building, we usually specify bituminous waterproofing with insulation. This is actually is a lesson learned from one of our contractor, Nakano, who has done a lot of data centers. Why? It's because it's fast and easy to maintain. When there's a leak, you just need to cut, tear, and torch it back. So there's no more double concrete roof for us because it'll turn into a tank before we can see the leak. Or we don't use cement screeded waterproofing because you need to do hacking and wet work, so that will take more time. Whereas for metal building, we specify double skin insulated built-out metal roof. So while we maintain the top layers, the bottom layers serve as the protection. For walls, locally we just use brick wall with cavity, or thick lightweight blocks. Is straightforward, cost-effective, come with good thermal mass and acoustic separation. Whereas for metal building, it's prefab insulated metal panel, complying to 8414 or Class O, depending on building height and distance from adjacent building. The panel delivers air tightness, thermal control, acoustic performance, and fire resistance within a single integrated skin. Okay, data hall flooring. So raised floor, once the industry standard, it works as AC plenum and cable management space. But now all data halls usually just use electrostatic discharge or ESD epoxy coating, like what Elise has presented just now. All these changes are due to change of cooling system. So if you can see the image on top, that is the space below the raised floor where it's used as AC plenum. And then it's changed to just side throw fan wall. Everything sits on a concrete floor, finished with ESD epoxy coating. And next, they are currently exploring liquid cooling, where CDUs units is used to distribute coolant directly to racks. So this can increase rack density. Some pilot DC already using hybrid system, part air and part liquid. And yes, with CDU, we will see less power and water consumption. So, and smaller cooling equipment means more data hall, more servers, more revenue. But now, yesterday, I actually just learned that there's a new cooling method, which is immersive cooling, where they put racks directly into tanks. Okay, there's no more hack. That's how fast technology can go. Next, security system. So DC, basically, data is equivalent to money. So security works like layers of band walls. Previously, security is simpler, just 4 layers. controlled by physical barrier, CCTV, biometric scan. So when you see perimeter security, it means fence and gates around your development, means on the boundary line. Facility controls means door to your data block and man trap at reception area. Computer rooms control means the door to your data hall. Cabinet controls mean door to your cabinets, to your racks. And then as DC got bigger, it increased to 6 layers. The additional 2 is clear zones and service corridor. So clear zones is the secondary fence and gate and boom gate within the campus, designed for anti-tailgating, designed for vehicular anti-tailgating. And service corridor means is back of house maintenance route for maintenance staff. Next, fast track delivery. So you always hear about fast track delivery for data center, but what does it really mean? So here we compare 2 different type of project typology. One is a Soho 20-story, 3.5 meters floor to floor. Data center is 7 stories, 5 meters floor to floor. Both is equivalent in build up, which is 100,000 square feet. So one takes about 5 years from schematic to CPC, and the other only takes 1.5 years. But how do you achieve that? So let's look at Soho. Soho or any commercial project, sometimes client can take up to 1 year just to lock down schematic design. Basically, mainly because direction keep changing without clear design lead. Then sometimes it takes up to 10 months because of separate KM submission and BP submission, and then you have your separate tender and construction packages. Before it can hit the ground, that takes 36 months normally according to HDA. So that total up to 5 years. However, for DC, we have to freeze layout within just 2 months. We do one-stop submission. At the same time, we have to produce construction drawing. We even skip tender drawing stage before we hit the ground. And usually for this kind of size, it's between 9 to 12 months of construction period. And now we can even shorten it because most local authority who encourages data center, they have express development approval, which is EDA. You can start work upon one-stop submission from about 20 to 30 days. Okay, for consultant team. Local clients are very cost-effective, typically just 5 disciplines: MEP, architect, CNS, QS, and landscape. So scope is well-defined. Coordination just happen within these few disciplines. And then global clients come with a higher expectation and, of course, cost provision. Besides the standard discipline, they have their design brief usually comes with specialist consultant like facade, telco, security, sustainability, acoustic, and sometimes fire specialists. Both setup have their pros and cons. Smaller teams are quick and nimble with shorter communication lines. Bigger teams means better details, but more coordination across discipline and time zones. Of course, our scope expand and our inboxes multiply faster than our fee. Okay, and that summarizes our project delivery before DC boom and how it evolved thereafter. Next, poetry in sterile architecture. Okay, some architects may say DC are too technical, too sterile, best left for engineers. Sorry, but I believe otherwise. To me, there's always joy to be found in every project, whether it's expressive or restrained, complex or simple. Don't worry, I won't bore you. I'll just quickly run you through our design philosophy. This is not a design lecture series. It's just part of our story. Okay, injecting soul into efficiency. So regardless whether it's data center or other projects, we begin with any one of these 3 anchors. They guide how we respond, create, think, and create. So first is history and culture. Help us to interpret the design through the lens of site context and client's origin. Next, environment and constraint help shape our building and also material selection. Story and identity ensure the project carries client soul, authentic, purposeful, and human. So this is our first data center. It's for entity. This block is called Sora, means sky in Japanese. Entity is simply, but not exactly, Japan's equivalent to Telecom Malaysia. So here we explore clients' history and culture through their traditional Japanese houses. We integrate the garden and material into the building design. We loop the garden into deep office spaces to bring in light. And then the DC block is enclosed with solid double cavity wall for security and thermal control. This is the cross section of the building. The back is the data center, where it's enclosed with double cavity wall for thermal control and security. The curvilinear garden loops into the central of the building, bringing light and drama and creating a focal point. The front offices, which requires less thermal and security, we propose more glazing for natural light. So protruded window frames is actually imitating Japanese window screens frame. Shoji screen inspired the frosted glass to obscure building structure and services behind it. So bamboo fence inspired the MEP or AC latch lures. The different shades of champagne gold imitates bamboo natural colors. So bamboo screen inspired balustrade surrounding the curved staircase helped filter and diffuse light. So the curvilinear garden that makes a loop into the lounge area. Bonsai tree, like the ones in Japanese garden, becomes the focal point from the interior. So this next project, also for entity, the building block is called Yuki, snow in Japanese. Here we drew inspiration from clients' environment and a place with 4 seasons and their sense of identity. The 4-season master plan concept was inherited from earlier blocks, so we simply carry it through to Yuki. Yuki means snow in winter. We abstracted and combined snowflakes and entities lettering, the geometry, into facade patterns. Using cool gray tones and repetition to reflect the calm and quiet strength of winter. We took inspiration from the golden winter sunlight and echo it with champagne gold mesh inserts into the lures, into the gray lures. So these are the typical floor plans of Yuki. Yuki is actually a multi-story data center. So when it's a multi-story data center, usually the ground floor are the plant rooms and upper floors are data hall. Here we simplify the plans to protect clients' security and privacy. Sorry, these are the design of the lures on all elevation. This is a rear elevation. So the lures is extended above the roof level to screen cooling towers and MEP equipment. This is the image of the AC aircon latch. This has yet to be fitted out. These are some of the perspective of the building. So I also like to bring you into some of the interior spaces. Service lobby is where the racks and equipment move in and out. The floor finish is in PU coating for durability. So visual lobby is installed with turnstile and man traps for part of the layers design, security layers. So staging area is just off loading dock. It's where the servers are assembled, locked in cages before they are bring up to data halls. And service passage is the quiet network of corridors feeding each data hall on each side. Okay, this is another project for NTT. So this where we think data centers stop being infrastructure and start becoming architecture. It's a new campus for NTT. We drew inspiration from Japanese culture and NTT's own identity. The Hokusai Great Wave is Japan's most iconic wood block prints from Edo period. The Great Wave is also a symbol of change. So the painting evolved from traditional to contemporary, and we further evolve it into graphic design and facade patterns. It reflects the same spirit of NTT's new campus, a shift in business model to embrace a new wave of customers' growth and demand. The idea evolved into a wave-inspired facade. The crest and trough expressed through different shades of blue and white, taken from NTT's corporate color. The 3D waves shapes the relaxed office zone, while the patterns and color screen continue through DC wings, combining form, functions, and flow. So here are some of the perspectives showing the front 3D wave office area and the data hall blocks with the screen wave pattern. This is entirely a data center block. Okay, this is the last project that we want to show. This project came from a global client with strict BOD, but we still managed to find joy in it. The site was once a palm plantation, oil palm plantation, so we translated that memory into architecture. The slender facade lines echo the rhythm of palm leaflets. The champagne gold colored panels drawn from the ripened fruit. The blue-green glazing mirrors the green foliage. So this is how we choose to remember the land. And I'm glad that the client let us bend a little just to make it happen. So I like to conclude that when there's a will, there's always a way, including injecting design spirit into the most boring building. Okay, next, shaping public perception. As architects, every time we speak on a platform like this, it's just not sharing our opinions, it's shaping perception. With this visibility comes responsibility to fact check, to speak in integrity and ground conversation. Honestly, it frustrates me when the public is misinformed, especially when the noise comes within our industry. So for today, I would like to set the record straight out of respect for the profession that we represent. So definition and labels. Let's get the terminology right. So co-location, I think just now Elise also mentioned about co-location. What does it really mean? It's not building typology. It's actually multi-tenant leasing business model. It's just data center business model. How? Actually, it's run by data center operators, such as if you have heard of them, Vantage Data Center, Bridge Data Center, or AIMS. They lease space to companies like banks, SMEs, telcos, or e-commerce to store their data securely. Each tenant will bring in their own servers. And hyperscale is also not a building typology. It's actually also a business model. It's single tenant-owned facility. For example, people who own all these hyperscaler like Microsoft, Google, AWS, or Meta. They build their own, build and run their own massive campuses and infrastructure. They are cloud service providers. So the more servers they serve, the bigger they'll build. So sometimes, where they couldn't expand in time, they'll actually lease spaces from co-location facility. So, and they usually lease in a big amount of area, either per floor or per block. It's called wholesale co-location lease. Okay. So the only typology here is actually data center. There's no such thing as co-location data. It's not a building typology. So data center is not factory or warehouse. It's actually a mission-critical infrastructure closer to power plants, telco hubs, aviation control towers, or national digital infrastructure. So the design strategy, of course, is not to design a factory or warehouse. It's a highly engineered building for high-performance infrastructure. Next, purpose group. So let's look at what is actually a factory and what is actually a data center. So factory produces physical goods. Data center hosts digital infrastructure. So factory is designed for human and material workflow, whereas data center is IT uptime workflow that keeps internet alive. Factory houses machinery and exhaust. Data center houses high-density power and cooling. So factory fire compartments are designed to contain risk passively. When there's a fire, it only protects their own goods and machineries. Whereas a data center fire protection is very active. Suppression starts way before compartmentation kicks in. So when there's a downtime, it doesn't mean a loss of few goods. It means national and global disruption. Your emails, banking, WhatsApp, everything stalls. So while Singapore grouped this group under others, we here still put cloud under smoke and chimneys, factory. So now let's look at how bomber and architects group this typology. For example, so Malaysia has no dedicated DC categories, whereas we know it's a different purpose group, risk and engineering logic. So bomber based it on structure, load, and hazard class. We know bomber were being practical. So bomber uses factory as fire guidelines reference. Of course, we will comply with the code. We shall not comply as a design direction. So it's a regulatory shortcut, not a design truth. So as architects, we lead design clarity, show professional credibility, and design for the actual purpose group. So also for data center, you need to know the big picture. So when you don't have all the information, it's a dangerous perception. So some of the people who says data center consume too much power, yes, probably. Block land for housing, yeah, probably. Don't belong in cities, maybe. Don't create jobs, entirely false. So DC is actually backbone of our economy and community. It serves banking, healthcare, education, government services, e-commerce, social connection, cloud and AI. It definitely creates direct and indirect jobs. So the first group of people here, actually the first group that say is a dangerous, it consumes too much power and all that, they actually can solve the problem which they think is a problem themselves. They actually can stop subscribing TikTok, Spotify, stop online banking and shopping, stop using their WhatsApp or ChatGPT. So it reduce data usage, therefore reduce expansion of DC. So do they really think all their data go to clouds and evaporates? No, it goes to server racks in a data center. So from the moment we wake up, we're already online. Every click, every message, every payment goes through data center somewhere. It's the digital backbone that keeps our lives, our city, and our economy running. And behind every data center, there's an entire ecosystem of people, from engineers, architects, facility manager, IT specialists, security teams, to indirect jobs like logistics, catering, landscaping, cleaners, and local vendors. That's how DC have been serving us, silently but powerfully. So I hope that I have cleared your perception about data centers. Okay, company growth. So this part is a bit more personal. Our company grew fast, just under 5 years. What started as COVID lockdown turns out to be a blessing in disguise. While many struggle to stay afloat, we found a new path forward and we grew through it. Getting into data center is not even part of my plan, but it's the best twist. Our practice grew stronger, faster, and more resilient. So we had our software and hardware, or our IT was upgraded. So before that, we're using Gmail, and then now we have Microsoft 365, where we have our company's name at the end of our email address extension, proud. Used to store all our documents and drawings in just one drive. Now we have Microsoft SharePoint, Autodesk ACC, Procore, Bluebeam, Lark, depending who is the client, PMC, or contractor. Used to be Zoom, and now everything is in Microsoft Teams, which we think is more formal and professional. CAD and SketchUp is simple, effective, and affordable. And then we have Revit and BIM, which is 10 times the software cost and two times the hardware cost. We didn't just upgrade our software and hardware. We upgraded how we think, collaborate, and lead. Industry term. So we used to call fee proposal. Now everything is RFP, request for proposal. Consultant is AE, architect, engineer now. Client's representative is SME, subject matter expert. Schematic is SDD, site due diligence or technical due diligence. Authority is AHJ, authority having jurisdiction. Design development is DD, detailed design. Construction drawing is IFC, issue for construction. Contractor is GC, general contractor. Mockup is FOC, first of kind. The defect list is NAC list. These are just to name a few. Whether or not it's local or global projects, this is how the acronyms stick. This is how our office speaks now. From 2 to 18. Okay. So this project here that I'm showing is actually the project that I showed you just now, the first project. It started at 2016. At that time, it was just basically me and half of part one that I shared with this C2 lead consultant for that project. The project just took 1.5 years from schematic to CCC, and I actually spent 12 hours a day, 7 days a week, just to complete construction drawing within just 2 months. Okay. At the end, of course, I'm exhausted and fell really sick. And by 2020, we grew to 4. From 2 to 4, for the first time, I could breathe a little. So even during COVID, we never stopped celebrating festival or birthday thanks to GrabFood and Foodpanda. And at that period, we also have to level up as we started working with Arup Malaysia, Singapore, and Australia. I'm really grateful for their guidance until today. So thank you, Ali, if you are watching this later. And by 2020, we have grown to 8, and for a while, it was all-girls team, stylish, efficient, and fearless. Okay, lockdown actually turns to a blessing in disguise for me because less job availability in the market allows me to find the best BIM talents that I ever could. Even though BIM was new to us, we spent 12-hour days, including weekends, just to deliver what was required of us. This is when our culture really took shape, built on grit, faith, and quiet determination to deliver. Special thanks to Crystal, Kahui, Pei, and Joey, who were the backbone of our beam transformation. But unfortunately, they all have moved to Singapore since the COVID lockdown was lifted in 2022. Of course, for better currency and bigger exposure. But really, I really miss them. So over the years, I built some really close relationship with my team. Lockdown probably helped. They couldn't go back to their hometown because the highways were locked, and then malls were closed. And I'll never forget my 2022 birthday. I was down with COVID, quarantined at home, feverish, and still have to attend online meetings. Then suddenly, my team appeared on screen singing happy birthday with cake and flowers delivered to my door. It was really touching.
Okay, thank you.
Okay, see, I sacrificed myself for showing this video because there's no makeup and I'm in my pajamas.
Oh my God.
Yeah, for the sake of good entertainment.
Thank you, Peggy, for the chocolate. Okay, thank you, Crystal, for the flower. Can see it?
Okay, by 2023, we grew to 10, and by 2024 to 12. And that year, we finally made our first company trip to Bangkok, thanks to the income surplus from previous years. And early this year, we have grown to 18. And I also have a new partner, Elston in the audience. You want to stand up and say hi? Okay, and also there are many of my colleagues here to support me today, and honestly, I'm very touched. I promise I won't embarrass them, but I'll make them proud. Okay, looking at this photo, it reminds me that growth is not about numbers, it's about people, trust, and timing. With this foundation and culture, we are ready to take on our next evolution. Okay, finally, reflection and purpose. So before I close, let's go back to what's behind the service really means. A reflection on purpose, people, and why we do what we do. Okay, it's always our choice to design our future. COVID and AI change everything. Rejecting data center means we fall behind digitally, we lose investment, we outsource our infrastructure. It's just a short-term thinking. Embracing data centers means we lead regionally, we attract tech and capital, we own our future, we future-proof our nation. So, as architects, we only have two choices. Either we reject data center and fall behind, or we embrace them and design how our future looks. So like what Spider-Man says, with great power comes greater responsibility. So DC are like our lungs. AI and technologies are inevitable, like oxygen that we breathe unconsciously. Data centers are essential infrastructure like our lungs that keep us alive. We must learn to live with them, improve them, and make the best of them, like keeping our lungs healthy. We can always make data center better neighbors with smarter site selection and planning, aesthetic and urban integration, sustainability and energy efficiency, community communication and trust, innovation through design. So the picture on the left here shows a tech park in Beijing by ILab. It's an integration between urban park and data centers. Here locally, we have Bridge Data Center, one of the prominent data center operators in Malaysia, is already walking the talk. They built first Malaysia water reclamation plant within their Ulu Tiram campus, fed by IWK effluent, okay, via Johor Special Water Pipeline, via Johor Special Water Pipelines, and treated the effluent within their site for DC cooling. This is literally sustainability. It uses membrane bioreactor and reverse osmosis tech to recover almost 85% of water from effluents, helping reduce reliance on potable water for cooling. And remember, the CDUs that I talked about just now, same story. Yes, less power, less water, smarter cooling. So yeah, our industry already moving in the right direction. It's no longer about whether we need data centers, it's about how responsibly we live with them. Okay, so work is digital now, life is digital, AI is accelerating everything, DC typology will evolve and new typology will emerge. They're already exploring building data center in space. So COVID was the cloud wave, AI is the current wave, AGI is the next wave. Gen Beta born this year, 2025 to 2040, is your children and your children's children. AI and AGI is part of their life, is inevitable. As architects, we can't stay still. We either evolve with it or risk being swept away by the next wave. So Malaysia architects are no longer just catching up. We are actually shaping the global infrastructure that connects us all. So I hope you're entertained and maybe slightly upgraded. Thank you.
All right, thank you very much. Oh yeah, you can stay on stage. All right, so any question from the floor? I'm just curious about the bomber inspections after the building completed, or maybe before the building completed. Does this categories, this kind of building category under performance based?
It depends on the
I forgot.
it is depending on the building. If probably there is not a design accordance to UBBL where you have the maximum limit of volume and area, then fire specialists will be brought in.
Okay.
Yeah.
All right. Any further questions from the floor? How about the upstairs? Ding, 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 ding. I think it's quite interesting because from what I've seen, it's about 125 to 128 data center in Malaysia, and mostly in Selangor and also Johor. So we might see more data center coming out, right?
Yes.
Okay. There will be a lot more. So
because you're using AI now, right?
Yes.
You're using your ChatGPT. Everything is about AI and storage.
yes, and from what, if I'm not mistaken, our AI, especially the apps that we are currently using, I think the change is about less than 3 months now. Every 3 months, they always have a new upgrading to all our application that we use. So because of that increase, especially last time, if I'm not mistaken, in October, we have Selangor Development Conference in KLCC. They talk about how the development will be of data center in Selangor. So it will be spotted by the state's government. So there will be a lot more for in futures. Maybe right now you don't have any projects that are related to data center. They probably could come over around the corner. So any questions, especially on the design or maybe the technical things that you want to know from Architect Hall? Have the mic. Anyone? Or should I go down? It looks so formal now. Any questions from the floor? Tak ada? Yes. Yeah.
Good morning. My name is Elmi. As an architect, I'm a bit oblivious about this data center, learning about it now, and thinking that because of the technology that we are progressing, lead to us need to have this data center. But technology always starts big and becomes small. You can see computers in the 50s can take up the whole building, and now it's very small chips. Now, as an architect, do you think that building buildings for data center is a long-term thing, or it's just a trend that after a while, when the technology becomes more efficient and that they don't need big buildings, they can just have the data center in a suitcase, for example?
Yes, I believe so. Exactly what I think. That's why I said it will evolve. In the future, probably I'm not building data center, or it becomes even smaller, or probably the power capacity is, as the smaller it is, the more powerful it is. I'm not sure. They're even exploring the space. I cannot tell the future. Yeah.
It's possible actually because from what we've seen, if right now we want to go off grid, it's very impossible, right? Kalau macam suddenly one day I just don't want to on my phone or don't want to watch TV or computers, it sounds impossible. You get anxiety on the spot. All right. So any other questions from the floor? Yes. Oh, sorry.
I have a question regarding more like what are the health issues in long-term exposure, whether there's such a thing. I know that there's always technology that can help you to insulate against all this exposure and everything, but are there in data centers, like proximity to data centers, are they kind of like, you want to put some kind of guidelines, how far residential areas have to be, or is that something not an issue? You could, like you say, you can, you want to have better neighbors, you know, so is that something that is being worked on in the long term? Why is it that they are never like next door to me? Why is it you have to put? Is it a land cost that decides where they sit, or is it because of health risks? What is deciding? What is the most important criteria for where you put them? If it's a land cost, then I would understand that you can put them in a very, very remote area. But if it's health limitations or exposure, maybe is that something more serious?
I think it's land cost and size of land. Therefore, it's usually not in city centers. And they need a big space. So city centers' lands are limited. So therefore, the off-city center. And planning guidelines usually have buffer zones. I think it's more about, because there's a lot of power, just in case fire and all that. For health issues, I'm not so sure because it's actually powered by power, that's all. I haven't really explored on that. But to me, I live in technology century. I like technology. So I'm not sure about, I think like eventually we'll die. So I'm not sure. I just prefer to have my technology. So I'm very happy to build data center just for that.
All right. I just curious. I mean, when you have the data center, do you have this like a wave coming out from the data centers?
I don't know. That's why I said I know there's power only.
Doktor dia tak. Because I'm just curious.
Okay, whatever complaints that people have is like they always like power is cut off. Sometimes they don't have enough water. Just power and water basically.
Power and water.
Yeah. There's no one really thought about health issues so far.
Yeah, I think we should look into that because based on data from our healthcare, there's a lot of increase in terms of cancer and also heart disease. So probably we have to look into in overall factors lah. So it helps our building. Okay.
Okay, and maybe additional question from Mr. previously regarding the disaster management, because you basically usually you build the data center at remote area. What about the disaster management? Some maybe such as flooding and anything.
Sorry.
Disaster management.
Disaster management.
Yeah.
Oh, usually before if you want to build, 100 years flood will be checked. So it needs to be always on high ground, just in case there's flood. So your question is, if I demolish a whole site just for data center, will that cost? No, no. All the like surface water drainage and all that is all addressed by civil, whether you need detention pond or not. It's just like any other development where you have to flatten a land to build anything. So I don't think there's any disaster come out of it. Yeah.
This data center, it has to be flat, total flat. Yeah? It's not it cannot be at a hill area or something.
If there's any hill, probably it will be flattened depending on building footprint, different platform.
I mean, it has to be total flats lah.
Like any one of building, you just need to flatten certain areas just for the footprint of the building. Yeah.
Okay, all right. Any other questions from this side? Tak ada. Anyone from upstairs? I think the upstairs can just shout. I think we'll be. We have a powerhouse here. Yes.
More on planning questions. Thank you for the presentation. I think it is quite insightful to see.
Okay.
Just wondering, you mentioned that the data centers have many clients that put the data. How is it designed? Do they have a central area where they monitor them, or they have a specific area?
Yeah, they have a
how do they
control
actually
room.
put area?
Yeah,
So
they have a control room to monitor their servers. And sometimes, for example, if co-location means they lease spaces to, for example, banks and all that, officers are provided for those banking people to monitor their own servers, for example. Whereas a hyperscaler, of course, is run by their own, is actually their own facility. So, of course, they have like admin area with control center to monitor the servers. Yes.
I think you should choose some example. One is vertical, and one is a bit more sprawling. So meaning like the offices will be where these people are staying, but the data center will be where the other block. I think the first
Okay, per floor you mean?
How is it linked? Yeah.
Okay, I go, because there are two models of business. If it's co-location, means they rent out space, right? So every floor probably have a little bit of office space, and then the rest are all data halls. Those are for co-location, because you need office space for these tenants, for their maintenance people. Whereas for hyperscaler, because it's their own facility, it's just a main office probably on ground floor, a selected area, and not on every floor. So usually typical floors for hyperscaler is just basically data halls. They won't waste space for office. So it's very few office people in data centers.
In that case, in terms of security, it will be per floor. If there are different tenants, it will be controlled as one security or always separately?
So as you enter, you have this reception area, like I say. So there's a man trap. Man trap means it's a double glass, sliding glass, for example. So one person enter, then that person stay there before they go to the other side. So no one can anti-tailgate them. These are the security measure in the reception. So as you clear that, the secondary one is the lift lobby, the lobby area, and then goes to the typical floor with data hall. So data hall doors, they have all the biometric scan and card access. Yeah.
Okay. How about in terms of the services like loading on unloading area? Do they have the same system at the front side?
Same thing. For loading and unloading from the guardhouse area already, they got screening all the way to the loading area. And after that is again from the reception area before the data halls.
Also, they have the same reception, like the man traps also at the loading and unloading area?
Not for that. Yeah, I understand what you're saying. So the area, no, but I think they got screened before they can even go to the loading area.
Because my mind is like Mission Impossible right now. How I'm going to enter the data center to integrate the data? Because when we talk about like, for example, like hospitals, we always think about like when you have normal patient and then you have patient from the prisons or something like that. So we always think about the security on how people want to run away. That's the point. That's the time that you can do. So like for data center, security is very important. It has to come first because all this data is a cloud. So if they want to hijack one of the machine, it will be like how to enter it from other services area. So my mind is like that now. All right, any other questions? Okay, right.
You look familiar. Have I met you before?
Yes, I met you in your office before. My name is Beckham Law, architecture assistant. I want to ask a question more on the management side. So there's a lot of consultants and message coming in. How do you manage all this information? Do you assign a person to?
Sorry, to the architects or to data center people?
From the consultant, because the project is very fast paced. And how do you manage all the information coming in from the consultant?
So we have different coordination platform. Some consulting team or client, local consultant team and client usually use WhatsApp as the platform. Everything is shared through there, including drawings. I think it's sometimes not very professional. Global clients are more professional. They usually use Teams or Lark. Lark are also one of the platform. So yeah, it's more formal platform rather than just WhatsApp. That's how we coordinate. So everyone is there. You get like 20 to 50% in just that one platform for, texting, coordinating.
Okay, answer your question? Or is there something else? Okay.
And with all this information, it's very distracting to like look at emails and work. Like, so do you assign a specific person to go through all this, or
No.
everyone do it concurrently?
No, we just deal with it.
Okay,
If you need to action, usually you just get tagged to answer or action. So everyone is on it. You just have to check your messages, just like how you check your WhatsApp messages. Yeah.
It's like waking up, chat message. Close down also chat message. Shut down also close chat message.
Yeah.
Okay. All right. I want to ask about the design that you have this book, like 100 to 100 page of design requirements. So is that frequently changed, or there's a standards that we should look at?
No, like if your client is an American client, they have their own stack that they've been compiling, and they update version every year. Like what version now? You just use their latest version.
I mean, it's by company lah. It's not
Yeah,
like
yeah,
a standard.
It's just like
Yeah.
IKEA, for example. I'm sure they have a design manual. Like they use the same manual and go throughout the different countries and just study this and compute or vomit
Yeah.
out whatever you're supposed to do.
So Copilot really helps lah. You drag on the documents and then.
Yes.
Yeah.
Yes, correct.
Okay. Any other questions? Tak ada. Oh, ada. Yes.
Hello, good morning, Ibrahim here. If there were just two things that that you need to, if you wanted to get into the data center projects, business, what would those be? Two most important things for any architect wishing to get involved in a similar project.
Oh, how to get data center job? Is that what you're trying to ask?
Just two things you feel is the most important for anyone wishing to get into building data centers as architects.
I think you need a list of project experience that is related to data center, of course. Otherwise, they don't even look at you. So I'm kind of like lucky because I got my break before the boom. Yeah. And secondly, I think after some time, you kind of pick up on all the technical terms, industry terms from data centers. So you need to speak that term in order to, and also you need to know exactly what is needed to really coordinate and manage the project. It's very specialized. They have a lot of specialized terms, like what I showed you just now. And I haven't even gone into details yet. I'm not even going into those, all the room names that is weird, yeah.
Understand. Something like hospital design lah. When like the complicated punya part is on the terminology where it's not common to us. So we have to learn another. So I think this is the beautiful part of becoming an architect. You can become anything. Whatever project that comes to you, you can become that person. All right. Any other questions from the floor? Tak ada.